Hi, today we're talking about CCM8, Unit 4, Lesson 2, Negative Scientific Notation. It's just some definitions overall. Standard form of a number is basically the normal way we write numbers. For example, 211 or 1,269,000. It's just the normal way we write a number. Scientific notation is a way to write really large or really small numbers. For example, 1.7 times 10 to the negative 9th power is a very small decimal. And I'll show you how we switch from one version of the number to the other. Very important concepts. When we are writing numbers in scientific notation, let's try to use a template. It's always going to be blank times 10 to the blank power. So this first blank is going to be a number in between 1 and 10. It can be 1, but it cannot be 10. And it can be any numbers in between. So I'll show you some examples of what I'm talking about in a second. Vic number 2, very important concept number 2. The exponent is telling you to move that many places in value, not necessarily adding that many zeros to your number. So that's a very common misconception a lot of people have about scientific notation. And Vic number 3, if a number has no exponent, it's understood that its exponent is 1. So here are some numbers that are already in scientific notation. 4.2 times 10 to the negative 6th power. So remember when I said this number right here, 4.2, has to be a number in between 1 and 10. And this meets our criteria. 1.01 times 10 to the negative 10th power. Again, it meets our criteria. Or 9.9 times 10 to the negative 3. These are all numbers that will be very small because they have negative exponents. Here are some examples of numbers not already in scientific notation. 16.1 times 10 to the negative 4th power. So you see how this number here is larger than 10? That doesn't work for us. In the future, in a few more videos, I'll show you how to take a number that's not in scientific notation and to change it so that it is in scientific notation. Okay? Here we go. Here's another number, 113 times 10 to the negative 7th power. Not in scientific notation because this leading number is greater than 10. And then this number here, 0.02 times 10 to the negative 5th. This number is less than 1, so it doesn't work for us when we're looking at scientific notation. Always be careful of that when you see a problem. All right, let's change some numbers into scientific notation. These numbers are in standard form. They're very small. So we're going to be moving the decimal to the right, which means in our template, blank times 10 raised to the blank power, that our exponent here is actually going to be a negative number. The exponent is however many moves I make in place value. So that's what number will come up with will make our exponent. Here, in our number here, we're going to try to create a new number out of these digits that's in between 1 and 10. Remember, I said it can be 1, but it cannot be 10. So I'm going to take the decimal, move it over, and that will give us a new number in scientific notation. So I'm starting here. As I move the decimal, I'm going to count. So that's going to be 1, 2. I moved it 2 spaces to the, which way is that? Right. And my new number is 9.85. So let's check. This is a number in between 1 and 10. Got that. And this is how many places I had to move the decimal to get that number. Does that make sense? I moved to the left, so my exponent is negative. Also, if you want to think about, oh, a negative exponent means a very small number. Think about it that way. Start out with my template, blank times 10 to the blank power, and my exponent's going to be negative because I'm dealing with a very small number. And I'm just going to move places, 1, 2, 3, 4, and 5. So my exponent is negative 5, and my new number is 3.25. So this here represents this number in scientific notation. They are equal in value, just different in appearance. All right, this next one, oops, my template's off. The next one here, I'm going to have to move a lot. So I'm going to move, starting with the decimal where it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, not enough, 10. So that I moved it 10 places to the right, so it is, my exponent is negative 10, and my number is actually 9 as a whole number. If I stopped after I moved 9 places, I would have 0.9. That's not big enough. I have to have a number in between 1 and 10, so I had to move it one more decimal place over so that I get this new number as my scientific notation. All right? So that's done. Now we're going to change numbers that are already in scientific notation into a number in standard form. Again, these numbers are equal in value. I'm just changing their appearance. So here we go. I'm going to start with just rewriting that first number, 5.6. And I'm going to move now the opposite direction of before. So I'm going to move 4 places to the left. Start with the decimal and move 4 places. 1, 2, 3, and 4. And fill in your zeros. I like to put a 0 in the front of the decimal also, just so you can see, hey, I've got a decimal here, don't overlook it. And here's your new number. If I were to read this, that's tens, hundreds, thousands, 10 thousands, 100 thousands. So this is, what is it, 5,600 thousandths of a number of 1. So this is a very small number. Let's take the next one, 8.3. And why don't you pause the video and you try changing this number into a standard form. Did you get this? 0.083? Hope so. All right, here's our last number. We're starting with 2, and we have to find our decimal place. So 2 is a whole number. The decimal place in this whole number would be over here to the right of the number, and we're going to move 11 places to the left. So again, why don't you pause the video, you try this one, and then check to see if you did it right. Did you get this? 0.0000000002. Wow. Well, I hope you learned something.